Okay, let me share my screen. All right, like I said, should be from section 12 and 13. I'm going to be your TA. My name is Christopher Argueta. And if you guys want to contact me, please, let me see if I can do this real quick. One sec. All right, here we go. Please use my u.pacific email or message me through Canvas. I had a couple students in the past that use my pacific.edu email, and I don't check that often. So u.pacific or Canvas. All right, just a quick little like bio slide about me. So I'm a master's student in Jerry Size Lab, if you guys know who he is. He's a biochemistry teacher at Pacific, and I'm in the bioanalytical, biophysical, biochemistry track. Quick fun facts: I avoid haircuts. I love nutrition and fitness. I studied abroad in Spain my last semester at Pacific, well, in Spain, and I very much enjoy noise canceling headphones. And I want to do a PhD in nutritional biology. So that's that. And then the overview for today's Zoom meeting. We're going to go over real quickly the course requirements as well as some the grading breakdown. Then we're going to go over the schedule for the assignments for these laboratory / Zoom discussion sessions. Very briefly go over some safety in lab, and then you guys will do your lab safety quiz. You guys are going to have about 25-30 minutes for that. And you guys are all going to do it while you're still in the meeting. Then we're going to jump right from the safety quiz to the pre-lab quiz for experiment 11. And then once you guys are done with that, which I will give you about like 10 minutes to do the pre-lab quiz. It's not too bad. It's only 5 questions. Then we'll jump into the lecture of experiment 11, and then you guys will watch the videos on Canvas on your own. All right, so this lab, like I said, has a safety quiz. Everyone needs to get an 80% on. If you don't get at least an 80%, you have to retake it until you do get that 80%. The safety quiz is 50 questions. Each question is worth half a point, making the quiz a total of 25 points. And then the first time you take the quiz, whatever resulting grade you get for that first time will be the grade that gets input into Canvas, okay? And then, like I said, you have to get 80%. If you don't, you're gonna have to retake it until you do. And the safety quiz is gonna be available on Canvas. It should be published already. All right, so let's get into grading. So these Zoom meetings are mandatory. It's basically like showing up to lab. If you don't attend, then you will get docked 5 points. And then let's get into dry labs. So dry labs, you will only have one dry lab in this course. It's going to be dry lab 3, and it's a problem set on atomic and molecular structure. And that will be on September 1st or 2nd, I believe. All right, now we're going to get into pre-lab assignments. So you guys should have already completed pre-lab assignment for experiment 11. That is due before we start the Zoom meetings. And then each pre-lab is worth 5 points. And if it's not completed, you will lose 5 points from the lab for that week. So let's just say if you didn't do the pre-lab assignment for experiment 11, you will get docked 5 points from the report sheet / post-lab questions for that experiment. So you guys' first few labs will be turned in as lab reports on Canvas, and these reports include the report sheet and the post-lab questions. The lab report can be found in your lab manual, and then each lab report is worth 25 points. But also remember, if you don't complete the pre-lab assignment, you get 5 points deducted automatically. And then you have to upload the report 1 week from the Zoom meeting, and it gets uploaded onto Canvas as a PDF document. All right, and then you guys will have 2 full lab write-ups for this course. They're going to be the colligative properties as well as experiment 19, the aspirin synthesis lab. And then there will be a guideline uploaded on Canvas on how to write these lab write-ups on, but that's not going to be for now. That's going to be later on in the semester. So now I don't think you're going to see your first lab write-up until March 30th, I believe. So these lab write-ups are worth double the report sheets. They're worth 50 points, and you have 2 of them, so it's a total of 100 points. So it's a good chunk of your point right there. And then let's see, you guys also have to complete virtual lab simulations. They're basically like little videos that are attempting to be a substitute for like being in the real lab setting. Then you also have lab demo videos where you guys will watch a TA or a person perform the lab's experiments, and then you're going to use that to write down your observations from the videos into the lab report as you would if you were in lab writing down observations in your lab report. And then back to the simulations, each simulation is worth 10 points, and these simulations can be watched and redone several times before their due date, and the most recent score counts as your final grade. So you guys should all have 10 points for these simulations. All right, so the late policy is strict. If you're no more than a day late, you will get a 50% reduction from the lab report or whatever assignment that's due that week. And then if you're over a day late, then you will get a 0. Unless you have, let's see, I think I got chat. Yeah, if you guys want me to slow down or go back to your previous slide, just let me know. Let's see. All right, so I think I got a question in the chat about this slide. I'll also upload these slides after the Zoom session to people who attended the actual Zoom session. So if you guys need to like investigate the slides a little bit further on your own, you can totally have access to the slides after. Okay, so let's just keep moving with that said. So yeah, late policy. Unless you have like a doctor's note or a very valid excuse from like your coach that says you're going to a game or something, late policy is pretty strict. And this is just the point breakdown. So your report sheets, good chunk of your points. Your lab write-ups are a good chunk of your points. These simulations do add up. Safety quizzes, did I say 50 points? Yeah, we'll double check on the safety quiz, but it's 25, no, it's 25 points, not 50. That's incorrect. All right, moving on. This is the syllabus. You guys should have access to this via Canvas. This lab is going to be a little bit longer because there were no labs in the first 2 weeks of the semester. So it's going to be a little bit longer, but these labs generally don't run for too long. So except for this one. But yeah, you guys have a break and then you guys have spring break. So it's looking pretty nice. We got one more in the chat. It's good questions. I'm getting a question. Is it available to submit assignments with Google Docs? I'm not sure if Google Docs, if it works, then you can totally submit your assignment with Google Docs. I'll double check to see if your actual document is not like all funky after the submission. But generally, please, if you can, do a PDF file or something like that. But I'll check to see if Google Doc works after your submissions from the pre-lab assignments from today. All right, so let's go back actually. So experiment 23, got one more in the chat. Can we submit handwritten lab reports and pre-lab assignments? You can submit you handwrite it as long as it's really neat and legible. Notability is great. You can totally do that as long as you have like an iPad or something. That works. All right, cool. Keep the questions coming. Where was I? So yeah, experiment 23 is a little bit tough, so watch out for that. Just keep that in mind. As well as experiment 24. Let's see, and then here we start the actual full lab write-ups. The equilibrium properties is going to be your first full lab write-up, and experiment 19. And after that, you guys are done. Okay, so let's briefly go over safety in the lab. I know you guys aren't in lab, so let's just make this real quick. You have to have no food or drink allowed in lab, right? If it is in lab, it has to be sealed away. You have to wear safety goggles and your lab coat. Closed-toed shoes. Long pants are recommended. Blah, blah, blah. Let's see. All right, so hair has to be pulled back. Do not take the stock bottles to the bench if they're in the fume hood. Let's see, always recap stock bottles. Just generally keep the area clean. If anything gets damaged, report that to me. And then this is something that you guys should watch out for next semester. This always happens every semester. Whenever you come into the lab, you should you should put your backpacks against the wall. You don't put your backpacks onto the actual bench. And then always put the waste in the proper container that's usually in the fume hood. And then report all accidents to me, right? As well as turn off your Bunsen burner and the gas when it's not in use. And generally, you want to always arrive prepared with a plan for lab, okay? All right, now let's get on to the safety quiz. You guys will have 25 to 30 minutes to take the safety quiz. Remember, you want at least 80%. If you get 80%, you're good. So let me just see to make sure I did publish it. I didn't. Okay. Safety quiz is now published. You guys should go ahead and start taking that right now. And if you guys all can turn on your video while we're taking the safety quiz, then you guys can turn it off after, it doesn't matter. So let's say we're starting at 5:15. I'll give you guys until 5:45.
I was going to say that as well. The quiz has no questions on it.
Yeah, same for me.
Yeah.
Me too.
Same.
Safety quiz is blank. Okay. Let's double check that. Give me 1 second. Does anyone see the safety quiz as not blank? Or is it blank for everyone?
Yeah, like it says that it's like has 50 questions, but then when you like go into it, there's nothing there.
Yeah, it's blank and the time's still running too. So it like when you start, the
Okay.
time's still counting.
That's super weird. All right, well then, in that case, that might take a while to fix. So let's move on to the pre-lab quiz. No, free 25 points, that'd be nice. I'll fix that after our Zoom session, and you guys can take the safety quiz at your own discretion. But yeah, let's go ahead and do the pre-lab quiz. That should definitely not be blank. So let me go ahead and publish that.
Do you just want us to press submit?
It's blank. Okay.
So should we just press submit on
Alright.
the blank quiz?
Can I get someone to say in the chat to make sure that the pre-lab quiz for experiment 11 is not blank? Pre-lab quiz should be in your module for week 1. It should say experiment 11 pre-lab quiz. Not blank. All right. So cool. All right. So you guys have 10 minutes to take that pre-lab quiz. So let's give you that 10 minutes and then move on to the actual lecture. And I'll see if I can fix this safety quiz.
I have a question. Oh, Christopher?
All right. So for regarding question number 3 for the safety quiz, just pick the right one. One of them has an incorrect definition. They're basically just swapped. So yeah, that question got messed up. So just go ahead and pick the right statement for A or B. Yeah, safety quiz is not fixed yet. Don't know why. Just focus on the pre-lab quiz for now. All right, guys, 3 more minutes. All right. If you're not done with the safety quiz, or I mean the pre-lab quiz, please wrap it up because we're going to continue with the Zoom session. Okay, so we're skipping the safety quiz for now, and I'll let you guys know via message on Canvas today or tonight when it's all ready for you guys to take on your own. Okay, so moving on to experiment 11, which is titled periodic table and periodic law. So the objectives for experiment 11 is to become familiar with the periodic table, observe and generalize trends of various atomic properties within groups, as well as the periods of these elements, and then observe from experimental trends the chemical properties within these groups and periods. Okay, so a periodic table is basically just an arrangement of the elements in order of their atomic numbers, so that elements with similar properties appear in the same vertical columns or horizontal rows. And then the vertical column is called a group, and a horizontal row is called a period. All right, so each square shows the chemical symbol of the element along with its name. It also shows the atomic number at the top of the square, which is the number of protons in the nucleus of an atom. The square also shows the atomic weight, aka the atomic mass, which is approximately equivalent to the number of protons and neutrons in the atom. Some people also call this the mass number. It can also show in place of that the average of the atomic weights of the different isotopes for that element, accounting for the relative abundances of the different isotopes. Okay, like I said before, a period is a horizontal row of the periodic table, and there are 7 periods in this periodic table. So with each one beginning on the far left. So a new period begins when a new principal energy level begins filling with electrons. So period 1 has 2 elements, hydrogen and helium, involving the 1s orbital, while periods 2 and 3 have 8 elements in them, involving the 2s and 2p orbitals. And then periods 4 and 5 have 18 elements in them, and these elements now have access to the d orbitals, which holds 10 electrons. And then periods 6 and 7 have 32 elements. These elements have access to the f orbitals. And then these 2 bottom rows that are separated from the rest of the table belong to those periods, 6 and 7. They're pulled out in order to make the table itself fit into a single piece of paper, basically. All right, so a group is a vertical column of the periodic table based on the organization of the outer shell electrons, the valence electrons. So there are a total of 10 groups according to the International Union of Pure and Applied Chemistry, but the traditional system in the United States involves the use of the letters A and B. So the first 2 groups are 1A and 2A, while the last 6 groups are basically 3A through 8A. And then the S, P, and D block elements of the periodic table are arranged into 18 numbered columns or groups. And then the elements in each group have the same number of valence electrons, 2 in the S, 6 in the P, and 10 in the D. As a result of this, elements in the same group often display similar properties and reactivity, because chemical reactivity of an element is mostly based on its valence electrons, the number of valence electrons. Okay, continuing with groups. So group 1 are the alkali metals, excluding hydrogen, and they have 1 valence electron in the outermost shell, making them very reactive giving them a tendency to lose that single electron. Example would be sodium. Group 2, we have the alkali earth metals. They have 2 valence electrons that tend to lose the 2 instead of gaining 6 to fill the octet, and they are just a little bit less stable than group 1. We have calcium here as our example. And then groups 3 through 12 of the periodic table contain transition metals. And transition metals have more valence electrons and are less reactive than metals in the first 2 metal groups that we just went over. Okay, so groups 13 through 16 each contain 1 or more metalloids. All group 13 elements have 3 valence electrons and are reactive and are solid at room temperature. And then all the elements in group 14 have 4 valence electrons and they are not very reactive. And the most familiar element in this group is carbon. So all the elements in group 15 have 5 valence electrons. And they vary in their reactivity, and nitrogen is, a very familiar element in this group. And then all the elements in group 16 have 6 valence electrons, and all are very reactive because they just need 2 electrons to fill their octet. And a familiar element is oxygen within this group. So those were the metalloids. All right, so group 17, these ones are called the halogens. So you'll be seeing reactions involving halogens in the lab videos on Canvas for experiment 11. So these halogens are highly reactive nonmetals because they have 7 valence electrons. So the halogens react finally with alkali metals, which have, remember, 1 valence electron. So the 2 elements combine to form a salt. And the classic example is sodium chloride. So sodium being the alkali metal with 1 valence electron and chlorine being the halogen. All right, so group 18 elements are nonmetals called noble gases. And these are colorless, odorless gases, and their octet energy level, outer energy level, their octet is full. And they have reached atomic nirvana. So they're chill and they are least reactive elements in nature. And they seldom combine with other substances. Okay, so now we're going to discuss some general trends in the periodic table, specifically the ionization energy, the atomic radius, electron affinity, as well as the density trends. Okay, so here are each of these trends shown in their respective plots. You gotta use these plots to answer your questions regarding trends in part A in the report sheet for experiment 11, but I will go over the trends using the periodic table in the following slides. Starting off with ionization energy. So ionization energy is the minimum energy required to remove an electron from an atom or ion in the gas phase, thus forming a positive ion. The general trend is for ionization energy to increase, moving from left to right across an element period. And then while moving left to right across a period, the atomic radius decreases. So electrons are more attracted to the nucleus because they're basically just closer to it, thus requiring more energy to remove them. So that's why it increases the ionization energy. And the general trend is for the ionization energy to decrease, moving from top to bottom, or increase, moving from bottom to top, down or up a group. So moving down the group, a valence shell is added, creating more distance between the outermost electrons and the nucleus. So the valence electrons are further from the positively charged nucleus, so making them easier to remove. Okay, so now we're talking about atomic radius. So atomic radius is generally stated as being the total distance from an atom's nucleus to the outermost orbital of electron. So in simpler terms, it can be defined as something like the radius of a circle, where the center of the circle is the nucleus and the outer edge of the circle is the outermost orbital of electrons. And then the actual trends that are observed with the atomic size have to do with three factors. These factors are the nuclear charge, which is the number of protons in the nucleus. Number two would be the number of energy levels holding electrons, as well as the number of electrons in the outer energy level. Number three would be the number of electrons held between the nucleus and the outermost electrons, the valence electrons. That one is called the shielding effect. So, but generally the atomic increases from the atomic radii increases from top to bottom in any group, and the atomic radii decreases from left to right across a period. But you guys should note that this trend is not systematic for the transition metals because other factors do come into play. So things get a little bit funky with the transition metals. Okay, next would be electron affinity. Electron affinity is a measure of the energy released when an extra electron is added to an atom, creating a negative ion. So basically, it's the likelihood of the atom gaining an electron. Let me just say that again. So the electron affinity is a measure of the attraction between the incoming electron and the nucleus. So the stronger the attraction, the more energy is released. So in general, the electron affinity becomes more negative as we move from left to right on the periodic table. It increases. And the electron affinities become less negative from top to bottom. So the greater the distance, the less the attraction. So the less the energy is released as electron affinity. Okay, so density. So within the group, density increases from top to bottom. And then while both mass and volume, due to an increase in the atomic radius, are increasing as one goes down a group, the rate of mass outpaces the increase in the volume. Okay. So this slide is basically just showing, like, as you can see here, red is really dense. So the density peaks are what we're seeing in the slide is the density peaks in the middle of the periods. So with regards to the fourth through the 7 periods, it increases from left to the middle with a really dense peak here, and then kind of like decreases more rapidly from the middle to the right. Okay, so moving on to what you guys are actually going to do in your lab report. Okay, so for part A, you'll just be using the trends of the periodic table. You guys could use these slides, which I will send you after this lecture, or the figures 11.1 through 11.4 in your lab manual to answer those questions. So let me get some responses in the chat, or if you guys want to shout out real quick. But let me just ask you, so if you see a question that asks, like, does the ionization energy get higher or lower as we move across a period of elements, what are you guys going to write down for that question? So does the ionization energy get higher or lower as we move across a period of elements? Higher. Yes, so generally, higher the atomic number results in a higher ionization energy. Awesome. Okay, so that's basically that's what you're going to be doing for part A, just answering questions based on those periodic table trends. And then for part B, you'll use the video on Canvas to write down. So there will be videos published, which I'll publish right after this. And you guys are just going to go on Canvas, watch the videos, and write down specifically for part B, the physical state of the reaction that you see, the physical appearance, and the color of the selection of the elements. Color of the elements. So basically, you're just going to be writing down your observations for part B. Really simple stuff based on like physical states, appearances, and color. And then for part C, you'll use the videos on Canvas again to see if a reaction involving halogens occurred or not. So if a reaction did occur, you have to write down the net ionic equation. Remember, which is a chemical equation for a reaction that lists only those species participating in the reaction, no spectator ions. So if a reaction does occur for the reaction in part C, then you have to write down the net ionic equation for that reaction. And that's pretty much it for part C. States of matter for the equations. Nah, don't worry about that. Good question. Okay, so for part D of the lab, you'll describe you're going to be seeing a halide metal mixture and I think 12 test tubes. And you're basically just going to describe this halide metal mixture using the videos on Canvas. So you want to check to see if the mixture is soluble, right? Dissolves in the solution, or if there is precipitate. If you guys see a little bit of undissolved material within the test tube. So you want to write down the chemical species that results from the reaction and write soluble if it's soluble, or write like low solubility if it's not too soluble. And if it's completely insoluble, then you want to write precipitate, or you could just write PPT for short. Let's see. Also write down the color and the general appearance of the precipitate if a precipitate reaction does occur. And if no reaction occurs for these reactions in part D, write no reaction. Okay. Then for part E, you have a couple sections for part E. So part E, point 1, you're just going to see on Canvas an exothermic reaction involving sodium and water. And you're going to write down the chemical equation for the reaction among some other simple things. All right, so moving on to part E, point 2. So once again, using the videos on Canvas, you want to note the observations that you see in these videos for part E, point 2. Basically, you want to focus on precipitation and no precipitation. So write PPT or no PPT in the first column, and in the second column, write PPT precipitation stays or PPT dissolves according to what you observe in the videos. And then for part E.3, skip it. We're not doing E.3, okay? And then finally, for part E.4, use the video on Canvas to answer the questions regarding the acidic reactions, such as which acid is more stable, based on what you see in the video. Oh, okay, let's go. Let's see, post-lab questions. So after you fill in your report sheet for all those parts on experiment 11, you should do your post-lab questions, 4 through 7 only. Don't do all of them. You only need to do 4 through 7. Okay, so we're closing in on the end of this lab, so let me just wrap up some reminders and due dates. So what was due today was the pre-lab assignment for experiment 11, and you guys already did your pre-lab quiz for experiment 11. What's going to be due are And our next Zoom session is going to be the pre-lab assignment for Dry Lab 3. We're doing Dry Lab 3 next week. That's going to be due before we actually meet, so before 5 p.m. February 2nd. And then this week, remember to do your 3 virtual lab simulations. I think you have 2 on lab safety and 1 on experiment 11. And then your report sheet, along with those post-lab questions 4 through 7 for experiment 11 will be due before we meet again next Tuesday on February 2nd at 5 p.m. Remember, if you want to contact me, use my u.pacific email or message me through Canvas. The PowerPoint will be given to those of you who attended. Don't worry about that. Stop sharing. And then I will send out a mass message on Canvas tonight when I finally get that safety quiz working. No idea why it's blank, but you guys will have a week to do it. Remember, you need to get 80% on that.
So
is
we
the
just
second lab section on Thursday mandatory, or is it just office hours? Yeah, it's not mandatory, it's just office hours. So if you guys, we're only meeting on Tuesdays, that's the only mandatory part. All right, and if you guys have any questions for me,
I was gonna add.
Otherwise, you guys can start watching the videos if you want to right now and get cracking on experiment 11.
Yo, can you guys not hear me?
If you guys don't have any questions, you guys can log off.
Yo,
I'll be
hello.
around answering any questions.
Somebody's asking a question. I don't know if you can hear them or not.
Yo, hello.
I can hear you.
Oh,
Yeah, I can't hear you for some reason.
oh, okay. I'll just type it.
Wonder why. Let me see if I can unmute everyone. Can you guys unmute yourself?
Mm-hmm.
Yeah,
Yes.
looks like you guys
Yeah.
unmute yourself.
Yeah.
Hello.
Wow. Yeah.
Yeah. Hello.
I don't know why I'm getting. No, you guys are not being assigned into groups. You guys can do these on your own. Or you can do it with me if you want. What? Maybe it's because, let's see. Yes, you guys can leave now if you want. Otherwise, I'll be sticking around to answering questions. Yeah, the safety quiz, I will open that up tonight, and then you guys have a week to take that. For sure, for sure. Yeah, sorry about all the
Thank you.
technical difficulties.
Thank you.
Have a good night.
You too.
Thank you.
Thank you.
Oh, is lobster due at 8?
Lobster, the simulation?
Yeah.
No, that should be. Does it say it's due at 8 p.m.?
Oh no, I'm just going off last semester.
No, I'm gonna give you guys basically a week to do the simulations.
Okay. Thank you.
Hey, Chris, I have a question about the lab quiz. So like I submitted the one that was blank and I got 0 out of 25. Can you like fix that?
The safety quiz?
Yeah, because I submitted, you know how like there was like a blank answer sheet and I just submitted it. Can you like
I'll
change
I'll
the score?
totally fix that, and then you can, whenever I get it up, you can just retake it.
Cool.
Yeah, man.
I have a question.
Yes.
Are you posting the PowerPoint tonight?
Yes. I'm gonna do it right now, actually.
Okay. All right. Thank you.
Mhm. All right, Lakota, you have any questions, or are you just like away from the keyboard?
Now I'll just head out. Last semester we just all stayed in lab, so I was gonna ask like peers for help as I went along, but everyone left. So
Oh, you know what? I will totally get like a poll going and prepare people for next week so that we can like do a group.
yeah, no, it's totally good. I just didn't realize everyone was gonna leave.
No
All right,
worries.
thank you.
Yeah, sorry. Thank you.
Bye.